Welcome to this instructional video on drawing organic molecules, number 3. So here we go. C8H9ON. That's the formula we need to draw a molecule that fits this formula, and of course the rules of bonding. By the way, if you don't have your guide to drawing molecules out, stop the video, go find it, dust it off, and put it in front of you, please, please, please. All right. And then we have the formula, and this needs to be an aromatic amide with one hydrogen bond donor. Oh, wow. All right, we got a lot going on here. So when you see aromatic, you know that the molecule is going to have a benzene ring. That's pretty much what I've said. In our world, an aromatic molecule is going to have a benzene ring. That's a pretty good drawing. There we go. And, of course, you know there are bonding positions on every carbon of the benzene ring. I'm going to go ahead and put the hydrogens in, but you can replace the hydrogens with other atoms on benzene. So let's keep that in mind, okay? Now an amide, people get amides and amines confused. Some of you will on the test, tragically. I don't know what to do except to warn you and to plead with you not to make this mistake. Amines and amides are different, okay? An amide has this base structure. It has a carbonyl right next to a nitrogen, and it has that fragment, if you will. Okay, so basically you've got to marry these two things together, aromatic and an amide, fit the formula, and make it only have one hydrogen bond donor. So if it's me, I'm going to draw this ring first. And then I'm going to, well, first of all, that's 6 carbons right there. When you have a lot of carbons, and not that many hydrogens, you should probably be thinking about benzene. So we have 8 carbons and only 9 hydrogens. So I'm going to, but in this case, I've told you it's aromatic. But I guess what I'm saying is, if you have a lot of carbons, not many hydrogens, and it's possible, think about a benzene ring, okay? But I've even told you it's aromatic here, so I've given you the hint right away. Okay, so I'm going to draw the benzene ring, and I'm going to take a position off of here. I'm just going to go ahead and draw this carbon off. By the way, we've already used 6 carbons. So when I draw my carbon of the carbonyl of the amide, I'm just marrying these things together till death do them part. I already have used 7 carbons. Okay, now I've got to add another carbon to this molecule. Where am I going to put it? Am I going to put it on the ring? Am I going to draw a carbon off this ring? I say no, because I have asked you in this problem to only have one hydrogen bond donor. So I know I'm going to have only one nitrogen-hydrogen bond, because there's only one hydrogen bond donor. And you know, if you've watched the previous video, I said never, never, never draw a bond off the oxygen that's already in a carbonyl. Okay? So I know that I have to draw the carbon off this nitrogen and not put it on the ring and add the other hydrogen here. That would not have met the criteria. So this right here works. You've got aromatic, and if you want, you don't have to, because in these rings you don't have to show all these hydrogens, but it might not be a bad idea to go ahead and do this just to check yourself. There's 6, 7, 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogen, an oxygen and a nitrogen. Is it aromatic? Yes, it is. There's a benzene ring. Is it an amide? Yes, it's got a C double bond O nitrogen in it. Does it have one hydrogen bond donor? Well, of course it does. Look at that right there. There's our one donor. So this meets the criteria. Okay? Now, what if you'd have drawn this, though? and you didn't read closely, and you forgot about the donor requirement, and you would have put this. Okay, and you could have put this carbon off any of the other 5 carbons you wanted to. Alright, so if you would have done this, would it have met the formula? Yes. Is it aromatic? Yes. Is it an amide? Yes. But does it have only one hydrogen bond donor? No, it's got 2. So, ladies and gentlemen, that's not going to get it. Okay? Again, this was a good review of aromatic and then amide, and trying to marry these two together to kind of meet the criteria. This concludes drawing video number 3.